Hello, everyone. So this was the number 24. So the question gave us an expression, and then we want to plug these for numbers to see how many of these are going to be integers. The first thing is like 2022, which is an even number, which has a 1, 2 as a divisor. And if I divide by 2, that will be integer. And if you square like this number, you got 2 2's. So you can divide by 4, that's also integer. When you take the fourth power, you have 4 2's divided by 3 2's, which is integer. Same reason with that. So which means this is integer. So for the next one, this is the like number that like the year before. So we need to remember that prime factorization as well. So that should be this one. So, but before I kind of plug this, I'm going to simplify this a bit. So I'm going to just multiply this by 4, 2, 1, and 1. So this entire expression would be like 4m plus 2m squared plus m to the 4th plus m to the 8th, right? And then this all over divided by 8. So we want to find this guy to be integer. So another way I was writing this, we can just say like 4m plus 2m squared plus m to the 4th plus m to the 8th has to be congruent to when you divide by 8. So if this is achieved, then we are good. So what I'm going to try now plugging this, but this 7, if you take the mod a, so that should be -1 times 1 to the second power. So you can just use this instead of those big number. So that could be equal to 4 times m, which is equal to -1 times 1 squared plus 2 times m squared. So you square this guy, or you can square this guy. So that should be the square of -1 is just 1. So that's also 1. And then the next one is m to the 4th. So you take the 4th power. So this entire thing is just -1. If you take the 4th power, so you got 1. And then if you take 8th power, so that's also 1. So now we got like, this is -4. This is 2, 1, 1. So that's actually 0, which means this is also this integer. And if I do the same thing with the 2024, so we can just remember 2024, which is equal to 2 cubed times 11 times 23. So we can just see it like we have 3 2's, right? So we have, this is divisible by 2. If I take a square, so you got 6 2's divided by 2 2's, that's divisible. And the same reason with like, if you take the 4th power, you got 12 2's divided by 3 2's, and then you just see they're all going to be integers. So we are good as well. And the last one, like 2025, so which is the year next year, right? So we need to remember the prime factorization as well. If you don't, it's easy anyway. So 2025 is divisible by 25. So 5 squared times like 81, which is 3 to the 4th power. So now we can just plug this into the expression right here. So that should be 4 times 5 squared, 3 to the 4th, and then plus 2 times m squared, so 5 to the 4th, and 3 to the 8th. So you got m to the 4th, so 5 to the 8 times 3 to the 16. And the last one is the 8th power. So that should be 5 to the 16 and 3 to the 32. Hope I didn't mess anything. So if I take the mod 8 now, so we can see this is 4. This is -3. So you square, that's 9. And then 9 is just 1. And negative, like 3 to the 4th power is 81. So if you take the mod 8, so that's just 1. And then 2. So this was same as like 5 squared, which is 1 square. So that should be 1. And then this is going to be 3 to the 4th square, which is 1 squared. And then the next one is the same as like 5 squared, because that was 1. If you take the 4th power, that's also 1. And then 3 to the 8 is the same as 1. So we got 4, 2. Okay, so that should be one more. Another 1 right here. And then this is also 1. That's 8. So that's congruent to 0. So that means this is also integer. So based on this, I got 4 of them are to be integers. Okay, so that was number 24.